Good day, my name is Francois van den Heever, student number 657-32790. This is my INI 3601 automated car parking system ladder diagram simulation. So firstly we can start the simulation. This is the ladder code over here. It consists of 6 networks. We can save the project and then generate the code to check it for any errors. And now the code is generated, 0 errors, 0 warnings. We can say online simulation. And then just log in, say yes. And we are now logged into the PLC. This is a virtual PLC by CodeSys, so I'm not using an actual PLC connected to the computer. And now we press start to start the PLC program. So networks 1 and 2, or rather network 3 and 4 is a copy of network 1 and 2. It just applies to the exit boom gate. So I will only explain network 1 and 2, and network 3 and 4 then won't be necessary. I will just briefly go over it because it's an exact copy just with different variables of the gate operation. So the entry detect sensor becomes true when a car stands on it. So the car stands at the entry gate, and what happens in this case is we have this normally open contact becoming true. 0 spaces remaining is a variable that will, if there are 0 spaces left on the counter that we will visit in a moment, then it will open up since it's a normally closed coil, and it will not allow any other cars into the parking grounds. So it will not open the gate if there are no spaces remaining. The first thing that happens when this becomes true is the entry spike servo this is an execute function block with structured text, and basically the spike barrier gets sent the variable of -45 degrees, and that will anti-clockwise lower the spike barriers. And then we have an on the lane timer, and this times 5 seconds of delay. So we have our time set to 5 seconds, and after the 5 seconds have passed, it will then open the boom gate with the open servo structured text set to -45 degrees for the servo controller. The next thing that it will also do at the same time is set the green entry light. This is a set coil for the green entry light, LGN. The red entry coil was initialized to true, and this is then reset so that it is off. And the validate entry is then set. The reason for the validate entry is in network 2. We set this so it will activate the validate entry coil. And if the car then drives through, then we have this validate entry set. And now we have a past boom detect entry, also a subsurface sensor, and the car will now go on to this sensor. The reason for validate entry is because we do not want a false trigger on this sensor to initiate a count of the spaces remaining, because the car in coil will be responsible for the count. So we need to verify with validate entry that a car has in fact passed through the gate. And at this point we can write this to true, so control F7. Validate entry will now switch off. So this coil is then, validate entry is then reset again over here for the next car. And now the spike barrier will go up again, so written back to 0 degrees. And the boom gate will be written back to 0 degrees. And we have our green entry light coil reset, red entry light coil set again, so that it indicates that we cannot go through the gate. and car in is counted. So this coil sets momentarily. We can just write this back to false. And now what happened is, if we just skip the exit network, if we go to network 5, there's an up down counter, and we can see that our preset value that was loaded is 10, but now one car entered, so we have 9 spaces remaining in the car park. And that was counted with the car in, which is connected to count down, to the counter down part. If a car exits, which we'll do in a moment, then it will count back up with car out. This is the 0 spaces remaining variable. So in network 1, if that becomes 0, if that becomes true, then it will not allow any more cars to enter the car park. And there is a one-shot rising edge trigger that is used over here to load the preset value only once, so that it doesn't reload every time that the PLC makes a scan. So now we have 9 spaces remaining, and the 9 spaces remaining is displayed in network 6 on this execute structured text block. So it's a case statement. It is similar to a switch statement in C or C++ programming. The case of statement will evaluate spaces remaining, and at the moment it's equal to 9, so we have case 9. And then these variables are written to the 7-segment display. So A1 through G1 is the most significant digit, or in the visualization this segment on the left, and A2 through G2 is the segment on the right, and each number is written accordingly to the 7-segment displays, 0 to 10. And now let's have a car exit again, just to show that this counter variable should go back to 10. So if we go to network 3, which is a copy of network 1, we now just have exit variables. So we can say the car reaches the exit sensor, the pressure sensor, and the exit spike barrier will now lower. 5 seconds pass, and we have the boom gate at the exit opening. The green light is set, the red light, the green light, no, sorry, let me just find that network again. The green light is set on the exit side, the red light is reset, and the validate exit is set. And now the car goes past the boom gate onto the past boom detect exit sensor, and we have a validate exit. So now the spike barrier can go up again, the servo can go back to 0 degrees, and we have a red light again on the exit gate, and car out has been counted. This is very important. So since the counter has been counted up again, we now have 10 spaces remaining. So that is the basic program. The rest of the details of the program is also explained in the final report. Thank you.